Hi everyone, Mrs. V here, and today we are going to build up a flowchart that will allow you to determine the charge on any ion and the valence or combining power of that ion. So this is pretty exciting stuff. Let's get to it. Let's start by getting a few of the pieces of terminology. Let's get the vocabulary under control. So first of all, we're going to look at the word ion. Now, ion is just a word that means a charged atom. Sometimes it can be a group of atoms with a charge, but when you see the word ion, it suggests there should be a charge on the species. Ions come in monatomic, one atom. It's just a single atom with a charge. Things like the sodium ion. Whoops. Sodium ion, the magnesium ion, the oxide ion, all of those are single atoms and the atom bears a charge. Sometimes though, you can get a group of atoms held together with covalent bonds, and the molecule that's formed by that has a charge. These are things like, say, the sulfate ion. SO4 is the molecule, and the overall thing has a charge of 2-. Another example would be the hydroxide ion. The molecule is formed by an oxygen and a hydrogen, but the overall molecule has that negative charge. And the valence of an ion is given by its charge. So if you can work out the charge on an ion, we can work out what its valence is. So we're going to build up a flowchart that tells us about this. So I'm going to get myself a spare bit of whiteboard, and we're going to think about building up this flowchart. So we're going to start just generally with all ions. And the first decision you're going to need to make is whether or not we have metal or non-metal atoms. So our first decision is we either have metal atoms or do we have non-metal? So that's the first thing you need to decide. The reason we need to decide that is that this tells us about the charge. So metal ions have a positive charge, and ions containing non-metals have a negative charge. That's the first thing. After that, if we're looking at metals, we need to know whether the metal in question is in group 1, 2, or 3. Or whether it's a transition metal ion. And you'll always have a periodic table in front of you, so you can look at that. And if we have group 1, 2, or 3, then the charge is the same as the group number. So everything in group 1 has a +1 charge, everything in group 2 has a +2 charge, and everything in group 3 has a +3 charge. And its valence is its charge, so our valence is equal to its group number as well. If we're looking at a transition metal, we need to look at the name. There will be a Roman numeral. And that's going to indicate what charge it has. So, for instance, the iron 2 ion, or iron 2 ion, is Fe2+. But if we were looking at the iron 3 ion, that would be Fe3 plus. And again, our valence is equal to our charge. So here, our valence is equal to 2 for iron 2, and our valence is equal to 3 for iron 3. And so the transition metals, if they don't have a Roman numeral, you assume a charge of 2. I'll try and remember to put the Roman numerals on all the time. There are some that I tend to forget. All right, so that's the metals sorted out. Now, when it comes to non-metals, you've got to look at the end of the name. So if the name ends in IDE, why is that not working now? I don't know. Oh, now it's worked. Okay. So if the name ends in "ide", then what that means is you're looking at a single non-metal atom that has a charge. And if we're looking at a single non-metal atom that has a charge, we can use the periodic table to work out its valence. So we know that we count the number of boxes away. If, however, you have the ending of 8 or ite, then what we're looking at here is a polyatomic ion. And when we're looking at a polyatomic ion, at this stage, you'll be given a table of polyatomic ions and you just look up its formula. And its valence is equal to its charge. There are a couple of nasty exceptions here that you're just going to have to remember. One of the things you'll learn about in chemistry is every rule seems to have an exception. So our exceptions are hydroxide. It's polyatomic, OH minus, but it's got the wrong ending. Cyanide is another one. And we also have the ammonium ion, which is even a positive one. So they're the exceptions you need to know. That is going to give you a really good, easy way to work out what the valence is on any ion. So I will see you in the next video.